Okay, so I'm going to go over these questions from the revision worksheet on calculus. So obviously going to start with the first question. So that was the question 4. And it says the function f is defined as below. So this is our function. And the question, the very first question, says find the coordinates of the point. So we're looking for coordinates of the point where the graph cuts the y-axis. So where it cuts the y-axis. So we have to think about where that could be. So let's have a look at a graph, just for an example. Badly drawn one. Okay, so let's look at a graph like this. So if we're looking for where the graph is going to cut the y-axis, remember this is your y-axis here. And in order to see where it cuts the y-axis, we have to actually think of the other axis. So at that point where it cuts the y-axis, all along this axis, x is equal to 0. All along that axis, x is equal to 0. So to find where the graph cuts the y-axis, we are going to do f of 0. So set x equal to 0, we're going to sub that in and then solve accordingly. And we should get a value of -9. Okay, so that's our y value. So y is equal to -9, so the coordinates are going to be 0, -9. So that's the coordinates of the point where the graph cuts the y-axis. The next point asks us to find the derivative of f of x. So let's have a look at that one, f dash x. The derivative of f of x is going to be 6x squared. So again, multiply by the power and reduce the power by 1 plus 6x minus 12. Okay, that's our first little bit of that question, find the derivative. Hence find, we're looking for coordinates, local max, local min. Okay, so the coordinates of the maximum and minimum turning point. Okay, what we should remember is that at a turning point, first derivative, your dy dx or your f dash x is equal to 0. Okay, at a turning point. So at a turning point, your derivative is equal to 0. So we can do that. We can set it equal to 0, 6x squared plus 6x minus 12 equal to 0. It's a quadratic equation, so we can divide across by 6 to make it easier for ourselves. We don't have to, but we can, to get x squared plus x minus 2. And at this point we can solve it the way we might solve a normal quadratic. We can use our minus b formula, it doesn't matter. We can use, in fact, maybe we'll just stick with what we had here previously and we'll use our minus b formula. So I'll let a be equal to 6, b is also 6, c is minus 12. So my minus b formula, we look at our formula and tables book to be sure what we're doing. Then we sub in again accordingly, so that's going to become minus 6 plus or minus the square root of, again, 6 squared minus 4 by 6 by minus 12, and that's all over 2 by 6. Okay, so now simplifying that a little bit more to give us less work in our copy, or in our calculator I mean, we can work out 36 minus, so 4 multiplied by 6 multiplied by minus 12. So again, calculator, keeping things as easy as possible for ourselves, obviously, as best we can. So 4 by 6 by 12 gives me an answer of 288 all over 12. That's going to give me minus 6 plus or minus the square root of 288 plus 36, 324, 12. Okay, and continuing on, again accordingly, we can get the square root of 324. So square root of 324 is going to be 18. So minus 6 plus or minus 18 over 12. And therefore we get that the answers for x are going to be, so minus 6 plus 18 will give us 12, and over 12 that's going to be 1, or x is equal to minus 6 minus 18 is going to give us minus 24, and divided by 12, that's minus 2. So what that means is our two x values that go with our turning points are 1 and minus 2. Okay, we can find the y coordinates. So to find y, sub in to f of x. So to find our y values, we're going to sub into f of x. Let me just move this down a little bit to give myself more room for this question. So first of all, we'll do f of 1. Okay, going back up to get our original formula, 2x cubed plus 3x squared. Let me just write it here. 2x cubed plus 3x squared minus 12x plus 9 minus 9. Okay, so that'll be 2 by 1 cubed plus 3 by 1 squared minus 12 by 1 minus 9, which gives me 2 plus 3 minus 12 minus 9. And if we have a look at that then, 2 plus 3 minus 12 minus 9 gives me an answer of minus 16. Okay, so 1 minus 16 is my first point. We can do the other then, minus 2. So 2 by minus 2 cubed plus 3 by minus 2 squared minus 12 by minus 2 minus 9. Okay, so that's going to be 2 by minus 8 plus, so plus 3 by 4 plus 24 minus 9. We get minus 16 plus 12 plus 24 minus 9, and that's going to give me an answer of 11. So minus 2, 11. Okay, so those are our two turning points. So we have 1 minus 16 and we have minus 2, 11. We can kind of tell from these points which of them is going to be the maximum point and which is the minimum point. If we want to test it to be 100% sure, we can use our second derivative. So my second derivative is going to be, so let me see, using my first derivative, I'm differentiating it again, so it becomes 12x plus 6. Okay, so comparing that to my first derivative up here, so this was my first derivative, and to find the second one I'm differentiating that again. Okay, so that's going to give me 12x plus 6, so when x is equal to 1, I get 12 by 1 plus 6, which is 18, and that's greater than 0, which means it is a minimum point. So it means for that value of x, I get a minimum point. When it's minus 2, it's 12 by minus 2 plus 6, which is going to be minus 18, which is less than 0. And that's my maximum point. Okay, so writing those down, we say minus 2, 11 is my maximum, and then 1 minus 16 is my minimum. Okay, we're asked then to sketch the graph of f of x, so we have to think about what are the points that we've been told. So going way back to the first question, we were told that the coordinates where the graph crosses the y-axis is 0, minus 9. So let's mark that one in first. So we cross the y-axis at 0, minus 9. So that's going to be around about here. Okay, what other points do we know? We know our maximum and our minimum points. So I can color them in here just so we can mark them off easily. So my maximum is going to be at minus 2, 11. So minus 2, 11, which is going to be here. And my other point is 1 minus 16. So 1 minus 16, again, it's going to be around about here. Okay, we have to think then, what does this graph look like? What would we expect? If we go back up to the top, we see it's a cubic graph. It has a cubed. So a cubic graph looks like this. Okay, it goes up and down. Okay, or similarly like this. Okay. If we're going to have a local maximum and then a local minimum, we would be expecting something like this, okay, because I'm hitting my max here and my minimum here, which is what we have in this case. Okay, so what I could do first is maybe link up the points that I do know, okay, as best I can, and then we're just trying to keep it maybe kind of somewhat symmetrical. Okay, so going on up that way and going on down this way. Okay, and we get a good solid sketch of the graph, okay, which again is the best that we can do for these points. So we use the points that we have, we mark them in as clearly as we can. So now with the way I've coloured over it, the points have kind of gone away. And just again, trying to keep it as symmetrical so that that is definitely clearly a maximum point. and that is clearly a minimum point. So just keeping it symmetrical as best we can. And if that's going to be your maximum, that's going to be your minimum. Just keeping those consistent. And then we have the point where it crosses the axis there marked in nicely as well. Okay, use your graph to determine the range of values of x for which f of x is decreasing. So where is this graph decreasing? So where is it going down? So it's decreasing this point here. Okay, so for the other two sections of the graph, it's increasing, then it turns and it's decreasing for a little bit, and then it turns and it's increasing again. So it's increasing between the two turning points actually. So my graph, I could say, is decreasing when x is smaller than 1, which is what I would say looking at this graph. When x is smaller than 1, so that's here, but when x is bigger than -2. Okay, so that's what I would give for that one. When it's smaller than 1 and bigger than -2. And that part there nearly is more from your functions than it is your calculus, but they're all related really, really closely. So we kind of can't have one without the other. Looking at the next question, so this question is about a climber and a distress flare, and it's close to kind of ones we've looked at to do with a rocket or firing something into the air. Okay, we see here that we have a -t², so a minus quadratic we would expect to look like that, and that would make sense for a question about maybe firing something into the air. So first of all, we're asked to find the height. So using the height function, find the height above sea level at which he fires the distress flare. So we have to maybe look back at the question and see, okay, well, where does that come from? And h is the height of the distress flare, t is the time in seconds after it is fired. So if we're asked to find the height at which it is fired, that's going to be when t is equal to 0. So fired when t is equal to 0. So we want to find h of 0. So that's 25 by 0 minus 0 squared plus 650. And that's going to be 650 meters. Okay, 650 meters above sea level. We're asked then to find the rate at which the height of the distress flare is changing after t seconds. So rate should make us think of calculus, and we're looking for our dh dt. How is height changing as time changes with respect to time? So looking at our formula we have up here at the top, we're going to differentiate that. So the 25t becomes just 25, the minus t² becomes minus 2t. Okay, and that's all we have to do for that one. For the next part, we have to find the maximum height. The maximum height. Okay, so let's find the maximum height of the distress flare above the position of the climber. So at that point, dh dt will be equal to 0. So that's going to be 25 minus 2t, which is then that 2t is equal to 25, and t is, sorry, let me rewrite that one, so equal to 0. So I have 2t is 25, t is 25 over 2. And we want to find the height at that time, so let's try and find h of 25 over 2. Hopefully that's not too loud. So subbing that back in then to the original one. Okay, so 25 over 2 here, minus 25 over 2 squared, plus 650. Okay, and then following that through, so let me just make sure we've that done it properly. There we go. So having a look at that one, 25 by 25 over 2. Okay, so 25 by 25 over 2 gives me 625 over 2. The 25 over 2 squared gives me 625 over 4. And then we're adding on 650. Okay, so we can work that one out fairly easily. Again, you're doing all this little bit using your calculator. You don't need to actually work this out mentally in your head. And we get a value of 806.25 meters. Okay. Then the ground at the base of the mountain is 400 meters above sea level. Okay, how long does it take the distress flare to hit the ground after it is fired? Give your answer in seconds, correct to 2 decimal places. So what are we being asked here? So we're asked how long. Okay, so we're looking for time. So we're looking for a time. Are we given a height then? Because this question's to do with height in terms of time. So are we given, if we're looking for time, we need a height. We're told 400 meters above sea level. Now what was h again? H was the height above sea level. So the ground at the base of the mountain is 400 meters above sea level. How long does it take the distress flare to hit the ground after it is fired? So we are looking for h of t. So we're looking for, t when h of t is equal to 400. So we take our h of t from above, 25t minus t squared plus 650, and we're going to put it equal to 400. Okay, so just tidying that up a little bit, we'll bring everything to one side. So t squared minus 25t, 400 minus 650 minus 250. And we're told to give our answer correct to 2 decimal places, which is generally a sign for us that we need to use our minus b formula. So we'll do that. And we're free to use the minus b formula regardless. So x is equal to, so we're subbing in, so it's going to be minus 25 plus or minus the square root of, let's see, minus 25 squared minus 4 by 1 by minus 250. Okay, and then it's all over 2a, so that's all over 2 by 1. Okay, so again, same as before, we're just tidying this up a little bit. So that's going to be a plus 25 then. Plus or minus, square root of 25 squared gives me 625. And the 250 by 4 gives me 1,000. So we're adding on, jumping steps there. So we're adding on 1,000 altogether. And it's all over 2 still. So again, 25 plus or minus the square root of 1625 over 2. Square root of 1625, which doesn't work out to be an actual answer. So at this point, we could sub it into our calculator and get our two values of x. So 25 plus the square root of 625 over 2 is going to give me an answer of 25. Or sorry, 1625. Sorry, I have the wrong thing entered. So I was thinking it should be a decimal. So there we go. So we get 32.65. Or sorry, 66 to 2 decimal places. And if we use then the minus value, or the minus version of that, we get minus 7.6, again 66. Now looking at what both of these relate to, and I really should be using the letter t there instead of x, because in this question it is t instead of x. But if we look at what it relates to, t is time. So in terms of our times, we can't have a minus time, or not relevant for our question. So our answer is going to be that at the time 3266, that's when the rocket or the distress flare is going to hit the ground again. Okay, we're asked to find the second derivative of h of t. Okay, so let's do that. So we have the first derivative. We can write it up here as a reminder for ourselves. So the first derivative was 25 minus 2t, which means my second derivative is just going to be minus 2. What's the significance of my answer? Well, that's going to mean that the function has a maximum value. And does that make sense? It does make sense. Because if we think of the shape of the graph, we said it looks something like that. It goes up to a highest point and comes back down. If you think of it again, you're shooting a rocket. It should have a highest point that it would reach. Okay, we need to use the height function to complete the table, and then we're going to draw the graph. Okay, so you could do this in two ways. You could simply enter your function kind of manually into your calculator and work it out for each step, or work it out for each point on your function in turn. So trying it, subbing in the different values of x, or you could use your table function on your calculator, starting at 0, ending at 30 with a step of 5, and that should give you your answers then. So we get 650, 750, 800, I get 800 again, I get 750, I get 650, and as expected we get the values going back down, because as my rocket goes up it has to come back down. So using the data in the table, we're going to draw the graph. So when we said when at 0 we're at 650, we're here. At 5 we're at 750, At 10 we're at 800, at 15 we're back at 800, at 20 we're at 750 again, at 25 we're at 650, and at 30 we are at 500 down here. And drawing a sketch of the graph, then we just link those points up. So make sure just that you're happy that you've got the points correctly. And a good thing to note there, I suppose, let me try that again, is this little bit in between the two highest points that we have there. So we have 2 points that were 800, but we would expect that our graph will go a little bit between those points. It should go up a little bit because it comes back down, but it has to reach a maximum point first, because our graph's not going to suddenly go straight at those 2 points. So it obviously goes up a tiny little bit in between them. We get something along those lines. We're asked to use the graph to estimate the time interval for which the height is at least 75 meters above the position of the climber. Okay, so let's have a look at that. So that's the height above sea level. Now we have to look at least 75 meters above the position of the climber. Well, where was the climber? Okay, so where was the climber? The climber was 650 meters above sea level. He was 650 meters above sea level. So if we wanted for the rocket to be 75 meters above him at all times, or at particular times, that's what we're looking to inquire about, we want it to at least be 725 meters. So we look for where that is. That's going to be here. We can draw a line straight across. So we're using our graph for this question. And we see where our graph intersects with that line that we've drawn. And then we make an estimate at where that point could be. So again, estimating we're at 4 and maybe 21 there. So I'll say the time interval, so I'm going to say for t between maybe 21 and 4, that for any time in between there, the flare is at least 75 meters above where the climber is. Okay, so some tricky parts there. That last little bit of having to work it out 75 meters above where the climber was and not just 75 meters was just an added little twist, I suppose. So looking at, let's see, the next question. Was this the last? Oh no, we have another one. Okay, so the last two. So we're halfway there. So let's look at this question. The diagram shows the graph of the function in a certain domain. On the same diagram, draw the graph of the function 2x plus 5. Okay, so 2x plus 5, again, we could try it out using numbers in our calculator just to plot a few numbers. What I might try maybe is with x is equal to 0, then that's going to be 2 by 0 plus 5, which is 5. So I know the point 0, 5 is on the graph. If I work out maybe one more point, when x is equal to 1, then I'm going to get the point 7. So I know the point 17 is on the graph. Okay, once I have 2 points, that's all we need to draw a line. And we should know from looking at this, because it is just an x, we should recognize that it is a line. So I'm going 0, 5, which is here, and I'm going 17, which is here. Okay, and then my line is going to be the line that connects those 2 points. Oh, and there we go. Not the worst one. Not the worst one I've drawn. Okay, so limit that back down a little bit. And I'll put extended on through here because we might have to look at how it intersects with the other graph. Okay, I'll just change the color. Right, so, oh, it didn't work. So let's have a look. So next question says, hence use the graphs, so the second part of that question here, says hence use the graphs to find the two values of x for which g of x is equal to h of x. So where they're equal is where the two graphs cross over. So it's round about maybe -1 and 3. So when x is equal to -1, x equals 3. Verify your answer by algebra. So g of x equals f of x. 2x plus 5 equals x squared plus 2. I can bring everything maybe to one side, so I suppose add it or subtract it from both sides. -3, and I'm going to get x minus 3 and x plus 1. Okay, and you could use your quadratic formula there either if you were unsure, and you get your two values, and we get the same values that we got from the graph, which is good. Then find the derivative. So find the derivative of f of x. So f dash x is going to be 2x. Okay, fairly simple. Find the value of x at which the tangent to the graph is parallel to g of x. Okay, tangent to the graph is parallel to g of x. What does parallel mean? Parallel means same slope. So we are being asked to find where dy dx is equal to the same slope as g of x, which means 2. Because if we look back at our question, g of x, the slope is the one in front of x. Remember we had the y is equal to mx. Oh, x is looking weird. Mx plus c, with m being the slope there. So we're looking for where the second derivative is equal to 2. So we set it equal to 2, and we get that x is equal to 1. Okay, and hence find the equation of this tangent. Well, to find the equation of a tangent, we need slope and we need a point. Okay, we have the slope, we don't have the point. So we know that x is equal to 1, but do we know what the y value that goes with that is? We can work it out fairly easily. We can pick one of them. So maybe we'll pick f of 1. We get, see, it was x squared plus 2. So it would be 1 squared plus 2, which is 3. So we have a point 1, 1, 3. So then my formula for the equation of a line is y minus y1 is equal to m on x minus x1. And I sub in my different values. Sub in 3, my slope is 2, this value here being 1. Y is equal to 2x minus 2 plus 3. So y is equal to 2x plus 1. That's our answer there. Okay, so let's look at the last question. So we're looking at the height of a diver jumping off a platform. It's given by this formula. So h is the height of the diver above the water. Okay, and t is the time in seconds after she jumps. So h is the height above the waterline. So essentially, if we look at our axis, this is the water. Okay, so there's going to be our waterline here. And then our y-axis is going to be the height above the water. So at time t, she's whatever height above the water. Okay, and if we're there, she's on the water. If h is 0, then she's on the water. So find the height of the diving platform. That's going to be the height when time is 0. So we sub in 0 for t, and we should just get an answer of 10. So what that means is that she's starting here. Okay, so the platform is like here at 10. Okay, find the length of time it takes before she enters the water. So to enter the water, her height above the waterline is going to be 0. Okay, so the height is going to be equal to 0. So obviously if we enter the water at a certain point, then our height is going to be 0. H is the height of the diver above the waterline. Okay, so obviously she goes into the water when the height is 0. So I've taken a second just to make sure for myself that I'm happy with what I'm saying. So we're going to set that equal to 0, and we're going to solve. I'm going to divide by 5, but you could sub it into your quadratic formula, that'll be fine. Whatever works for yourself. Okay, so we get an answer of t is equal to 2, or t is equal to minus 1. Okay, and those are our two answers. Obviously, if we're looking at time, we're not going to have minus 1, so we're going to go with the t is equal to 2. So at t is equal to 2, we're just going to go into the water. Find dh dt. Well, we just take our h of t as above, which is 5t squared, and we're going to differentiate that. 5t squared becomes minus 10t, the 5t becomes plus 5. Then find the rate of change of the height at the instant that the diver enters the water. So when does she enter the water? Well, we've said that's t is equal to 2. So we're going to find dh dt when t is equal to 2. So we just sub in 2, get minus 20 plus 5, we get minus 15. Okay, so that's the rate of change when she enters the water. Find the length of time it takes the diver to reach maximum height above the waterline. Okay, so important. This was what I was trying to figure out. The diver is starting here. Let me move my little diving platform. There we go, not a ledge. Okay, so this is her here on her little platform, and she's going to go up and down into the water. Okay, so she's diving into the water, so she's going up and going into the water. So find the length of time it takes to reach the maximum height. So maximum height, we should remember dy dx equals 0. So in this one it's dh dt, but that's fine. We go back and remember what that was. It was minus 10t plus 5 is equal to 0. So 10t is equal to 5, t is equal to a half. Okay, so it takes her half a second to reach her maximum height. Hence, find this maximum height. We can sub in t is equal to a half into our original formula. So that's our minus 5 a half squared plus 5 by a half plus 10. So I don't know why that zoomed in so much there. So a half squared gives us a quarter. So minus 5 over 4 plus 5 over 2 plus 10. And we can tidy that up a little bit then. So minus 5 over 4 plus 5 over 2 plus 10. And we get an answer of 11.25 meters. So that's 11.25 meters above the water. Okay, really in the previous part, we could just confirm that it is a maximum. We could get away without doing this, of course, but we can confirm that it is. We get minus 10, which is less than 0, which confirms that it's a maximum. Okay, that's our little extra step. And that's kind of the point that we've been saying, that if we don't get to that point now, then that's fair enough, but it's one we can bear in mind, just to confirm. That's your last few marks. The diver performs a different dive in competition. She reaches a maximum height of 0.75 meters above the diving platform after 0.5 seconds. So what does that mean for us? My max height is 0.5, 0.75 meters. Okay. After 1 second, she is at the same height again as her initial dive position. Okay, as her initial dive position, so where she started. The height of the diver above the waterline after t seconds is given by this formula. Find two expressions for the position of the diver in terms of a and b, and hence find the value of a and the value of b. Okay, so we have a little bit to do here. So we know what our maximum height is, and we know what time she reaches that height. So she reaches a maximum height of 0.75 meters above the diving platform, and that's important as well, above the diving platform. So we would have to first know how high the diving platform is. Well, we said it was 10. We said it was 10 meters, and we can see here it's still 10 meters. She's still at the same swimming pool, if you like. So at this point, that's actually a value of 10.75. So when I said 0.75 over here is actually incorrect. It's 10.75. So at a time of 0.5, she reaches a maximum height of 10.75. So a little bit lower actually than her maximum height in the previous part. So we can use that for our first part here. So if we do g of 0.5, we're expecting our answer to be 10.75. So we can try it out. It's a 0.5 squared plus b by 0.5 plus 10. And 0.5 squared is 0.25. So 0.25a plus 0.5b plus 10 is equal to 10.75. Because we know that is the y value. So simplifying that down, and we might be getting an idea now of what sort of question we're going to have. So this is one of our points that we're going to be using, one of our equations or expressions, as they've said there, that we're going to be using. So we need to do another one. So after 1 second, she's at the same height again as her initial dive position. Okay, so at g of 1, she's back at 10 meters above the diving platform. So what that means is a by 1 squared plus b by 1 plus 10 is equal to 10. So a plus b is equal to 0 then. That means that a is equal to minus b, and we can use that then in the previous part. So 0.25a, so let me see, instead of a I'll say minus b, plus 0.5b is equal to 0.75. We have minus 0.25b plus 0.5b is equal to 0.75. We get 0.25b is equal to 0.75 and b is equal to 3. Okay, so we know what b is, and then that implies then that a is equal to minus 3. Okay, so we were asked to find the value of a and the value of b, and that's what we've done there. A is minus 3 and b is going to be 3. And we can see kind of similar to the last one. The last one, the minus 5 and plus 5, and this time it's minus 3 and plus 3. So kind of seems like it might be sensible that the two are the same. So that's all of those questions there. So we see, again, that idea of finding first derivative coming up quite a lot, subbing back into the original formula coming up quite a lot, finding your maximum. I mean, you can nearly write the questions, okay? You're finding first derivative, you're finding the maximum. Okay, so you're following all these key ideas. You sub back into the formula to find out what is the actual value. You're always going back to find out the y values, all of those usual bits.